contrast to odd powers of trigonometric function, even powers are usually a bit harder for us to deal with. We'll have to use some new tricks to deal with problems like this. So let's take a look at this one, simplest one. Evaluate the antiderivative of sine squared of x. So there are two possible ways to do this. And so I'm just going to say here that one way you can do it is integration by parts. I'm not going to carry out that calculation for you here, but I'll just say the choices that you should make. You should split up sine squared x as sine x times sine x. And so then u can be sine x, and dv can be sine x dx. And in that case, du would be cosine x dx, and v would be minus cosine x would be your choices. So you wouldn't be done after you do this. There would be another integral. You'd end up having to find the antiderivative of cosine squared x. I'll leave that as an informal exercise for the time being. So now I just did one where I didn't do it. To actually carry through, we can use the double angle formula. Okay, so let's bring back this sheet from earlier. So this says that we can rewrite sine squared x as 1/2 minus 1/2 cosine of 2x. So let's do that. When we'd end up with the antiderivative of 1/2 minus 1/2 cosine of 2x dx. And so now this is something that we can do really easily. So the antiderivative of 1/2 would be 1/2 x. And then the antiderivative of 1/2 cosine of 2x would be minus 1/2 times the antiderivative of cosine of 2x would be 1/2 sine of 2x plus c. And of course we could just combine it a smidge. 1/2 x minus 1/4 sine of 2x plus c. And this would be a very easy one to check to make sure that we end up with this. Okay, so that is the antiderivative of sine squared. We can also have, for example, maybe we want to look at the antiderivative of sine to the fourth. Once again, what we would do, well, our first step would be to rewrite this as sine squared x times sine squared x dx. And now we're just going to say, hey, we're going to use our double angle identity again. So it is going to be 1/2 times 1 minus cosine of 2x. All of that, let me count my parentheses, 1, 2, 3, that squared. And when we expand this out, we'd end up with 1/4 times the antiderivative of 1 minus 2 cosine 2x plus cosine squared of 2x dx. So this is, I'm just squaring the term 1 minus cosine of 2x to get here. Okay, so at this point then, we can again evaluate much of this. So the answer would be 1/4 times the antiderivative of 1 would be x. The antiderivative of minus 2 cosine 2x, that would be minus sine of 2x, because when we take the derivatives of sine of minus sine of 2x, we'd have minus 2 cosine 2x. And so then that would leave us here with one more antiderivative to evaluate the antiderivative of cosine squared of 2x. And so just as we have formulas for sine squared of x. We have formulas for cosine squared of x. And so cosine squared of x would be 1/2 plus 1/2 cosine of 2x. Cosine squared of 2x would be 1/2 plus 1/2 cosine of 2 times 2x, which would be 4x. So we can make those changes. And so that would be 1/2 plus 1/2 cosine of 4x. And so this is, again, something that we can evaluate very easily. Minus 1/4 times x minus sine of 2x plus x over 2. And then the antiderivative cosine of 4x would be 1/8 sine of 4x. Because if we take the derivative of 1/8 sine of 4x, we would get 1/2 cosine of 4x. So just as we can do even powers of, so now I should say, let's summarize what we did in these videos. We can now know how to integrate even powers of sines. And so a next step to do would be, so I'm not going to do this in this video, but if we had sine squared x times cosine squared x dx, our first step would be to replace, oh, you know what, this is not bad. I can just go ahead and say, what is cosine squared x? Cosine squared x is 1 minus sine squared of x. And so what do we have here? Sine squared x minus sine to the 4th x. And guess what? We just spent our video evaluating the antiderivative of sine squared x and sine to the 4th x. And so we could combine our answers from the previous two problems to come up with the antiderivative here. Okay, so this is how we handle problems, trig functions raised to only even exponents, where we don't see any odd exponents around. Let's wrap things with a pre-class problem here. Pre-class problem number 2. Evaluate the antiderivative of cosine squared dx. So this should be a pretty easy, straightforward problem. I do want you to show me some work. Don't just write down the answer here. I want you to see at least one intermediate step. You'll probably be using one of the double angle identities from earlier.